So here's a second example at the bottom of page 2 from your notes. I have a function f of x is x cubed minus 1 over x squared minus 1, and it has a discontinuity at x equals 1. That means if I try to draw the function near the place where x equals 1, I won't be able to do it without lifting my pencil. So I've been asked to write a new function, an extended function that is continuous at x equals 1. Excuse me. So notice that extended function, all that means is we're going to write a piecewise function with this original function, the one that's given, as one of the pieces, and we're going to write a second piece with the only one purpose, to put one dot in the hole, to fill in the hole with one dot at the place where x equals 1. That's what an extended function is. So I'm going to start by factoring numerator and denominator, and when I do that, I see that this is a difference of cubes up top, and down below a difference of squares. So after I factored, I can notice that my x minus 1s cancel, which means that now I could plug x equals 1 into this expression, and I won't have a problem. I won't have a 0 in the denominator. So the limit, I want the limit as x approaches 1 of the same function. So because that's what continuity means. My function is going to be continuous if the limit from the left equals the limit from the right, and that's equal to the function value. So the limit from the left and the limit from the right now I can find happens to be 3 over 2. That means I need my function value when x equals 1 to be 3 over 2. I need the limit to exist, and I need the limit to equal the function value. So watch what happens. Here's my final answer. I'm going to have a new function that, as long as x is not equal to 1, is exactly the same as the function I started with. Then the one place where there was a hole in the function, where x equals 1, I'm just going to put one teeny tiny little piece, extra piece in my piecewise function to fill in that hole. This is our final answer. Here's a graph of the function x cubed minus 1 over the quantity x squared minus 1. If I had zoomed in on this function before I had filled in the hole, then right here where x equals 1, I would have seen a hole. But now this is the new function and that hole's been filled in. Notice here, x equals negative 1. I can't plug x equals negative 1 into this function either because it's going to make a 0 in the denominator. But the x minus 1 factor in the denominator didn't cancel out. So that means there's a much more interesting kind of discontinuity happening here. And you can see probably from this graph that actually what I have is a vertical asymptote here at x equals negative 1, which is why I can't remove this discontinuity. It's an essential discontinuity. The nature of this function is such that there's no like little filling in or little tiny fix I could make to make that discontinuity go away. Why care about continuity? It turns out that calculus, the calculus we're going to learn, spoiler alert, we're going to learn about slopes of functions, and then we're going to learn about areas under curves. It's the two big pieces of introductory calculus. None of that works on functions. Well, you can't guarantee that it's going to work on a function that's not continuous. So you have to understand continuity in order to confirm that our functions are continuous before we try to do calculus on them. So something to know, all polynomial functions are continuous. Think of your functions booklet. Were there any functions that you couldn't draw without lifting up your pencil? Those are the functions that have discontinuities. But there's parts of them that are continuous. So if we study them in calculus, those are going to be the parts we focus on, the parts that are continuous. So all polynomial functions are continuous. And you could add, subtract, multiply, or divide two continuous functions to get another continuous function. You could compose two continuous functions and you'll have a result that is still continuous. So if you don't remember this concept of composition, here I have y is the sine of x squared. That's a composition of the sine function, which is continuous, and the x squared function, which is continuous. I can know that the result will be another continuous function.